of take this view. The one class containing just so many as the other, because contact would be possible only between a body with a surface, only between a body with a surface and one without. And that's monstrous, according to Brentano, and so he does all this stuff to make it less monstrous. Namely, gunky stuff, infinitely many, right? Now, so apparently it seems to me that, I mean, Bolzano's monstrous doctrine just is an instance of Hudson's not. And apparently it seems to me monstrosity is in the eye of the beholder. I mean, they both seem pretty wacky. All right, now from a region-space perspective, so am I running out of time? Yeah, so we'll just very briefly, see that's kind of good, because I can tell you, I don't know from a region-space perspective, I don't have to get into any detail because I'm almost out of time. But of course there is the question period coming, so. All right, now, so let's go think of things from an Aristotelian point of view now, and wonder whether we're still going to get stuck with this same picture. So, from a region-space perspective, an Aristotelian one, that is where all objects are, all spaces, space itself is gunky. Right? There are points there, but they're just limits, so you don't have to worry about point size things and such. Two objects touch if the regions they occupy are contiguous, in Aristotle's sense, if they share a boundary. If they're separate objects, if they're contiguous, then their boundaries are together, they're in the same place. And if they're continuous, their boundaries just disappear, but they're sharing them somehow, right? The boundaries are in the same place. Consider, for example, an object A that exactly occupies a cubical region, and another object B that exactly occupies a neighboring cubical region. No distinction between the object being open and closed. That's a mistake to even wonder that. Boundaries are the boundaries of the objects. They're metaphysically tied to them. Clearly, A is in contact with B. One side of A is snug against one side of B. If we don't reify the sides of the objects and think of them as somehow separate from the object, then there's less temptation to think that the objects overlap. I'll skip this. Maybe, yeah. So this is a good place to stop then, as I said, because A, I'm out of time, and B, because we've sort of gotten to the, so I think I've sort of laid out that there are puzzles there, and the puzzles are much easier to negotiate on a Aristotelian picture. I'm not claiming there aren't any other ones, but those are easier to negotiate. So, thank you.
Question about Percy's puzzle, the one about the colors, if I remember correctly.
That's how Varzi puts it.
Yeah. So and its relation to the Brentano style solution to the problem of continuity.
Yeah,
so
not that Varzi finds that, but yeah.
Well, anyways, so I'll just tell you what I think, which is a question. If we buy what Brentano says, suppose I have a segment and I break it into two parts.
Yes.
What happens is that there are 2 points which used to coincide and they no longer coincide after breaking.
That's right.
Yeah? But now if they're colored, suppose the left part is white and the right part is black, now I suppose that after breaking, one point is white and one is black, but when they're not broken yet, what color is that? So it seems to me that Brentano's strategy doesn't work with color.
It doesn't solve, yeah, you're right, I hadn't thought of that, that's interesting. So Brentano's strategy does not solve Percy's puzzle.
Yeah.
Because you're wondering what color is the boundary, or what property does the boundary, well, no, sorry, yeah, that's right. Percy's puzzle presupposes that we're not in a Brentano type of, we're assuming that the boundary's got to go with one or the other. So the puzzle in effect presupposes that the boundary belongs to either the circle or the background. So it'll have whatever properties one or the other has. The Brentano picture is that it sort of belongs to, if it's an interior boundary, it sort of belongs to both.
Yeah.
No, I think I see it. I think there would be a real puzzle there. So imagine an object that hasn't been broken yet, and half of it is red and half of it is or half of it is black and half of it is white. And then you've got the boundary there, and then you could ask what color does the boundary have? Yeah. Yeah, and as far as I know, Brentano's solution wouldn't have anything to say to that. And if it did, it would be kind of a weird one, where, yeah, half of the, well, not half, there's infinitely many, but some of the boundary points are black and some are white. And if you happen to break it right there, it just so happens all the black ones go this way and all the white ones go this way.
And my question was simply based on the fact that if I remember correctly, Varzi likes Brentano's solution, and
I didn't remember that.
he develops a sort of theory based on coincident boundaries along Brentano's lines.
So then what would it,
And so I don't know how he would solve
that particular problem,
that problem.
I didn't know that, is this the same article that I was citing?
I don't remember. I read something many years ago.
I mean, quite often, people will write different things at different times that are sort of inconsistent with each other. But the paper that again, I do it, we all do it. I mean, it's not criticism. The paper that I was citing, I don't think he was sort of, he wasn't allowing that the boundaries could coincide. Which, but that's the object that's already been broken, right? If it hasn't been broken yet, then what do you make about these sort of internal boundaries? I don't think it's discussed in that article. I haven't read everything that Varzi's written, but if you say he does like the Brentano picture?
I think so, yeah.
The Brentano chisel one where, in effect, what you have in effect are infinitely many, or at least more than one, potential boundary points internal to the object.
And a related, a related issue I have is how many coincident points are there on a boundary? It seems to me that the Brentano picture underdetermines that. So for example, if I have a line, a segment, and I break it, I could say that I have 2 coincident points there because I could break it into 2 parts.
That's right.
But if I have a circle and I consider all the radiuses, and there are infinitely many radiuses that coincide on the center, so I will need to have at least infinitely, uncountably many points.
I would think continuum then.
Yeah, but the point is, why continuum many, not more?
Oh, not more than, I should have rephrased, at least continuum.
Yeah, but why not more?
Why not more? Right. Well, because you don't need more, but.
Yeah, you don't need more, but that's not.
Right. Well, don't multiply entities beyond necessity,
Yeah.
No, actually, I'm pretty sure that there must be a shift in Varzi's views, because his actual views on boundaries are that, like in the article that I was working with, if you take, let's say you take like a cube and you cut it, right? The picture that he has there is that the knife, when you cut it, will take the boundary that's around the cube and stretch it along the inside, and that'll become the boundaries of the internal objects.
But then you still have a point at the end.
Yeah, and he notes that you'd still have to worry about that, because he calls that a magical moment or something, but that's just one point, and he says, okay, you do have that problem, because you're changing the topological structure of the thing at some point.
Of course.
Right. But he says, look, but it's just, if you get it down to one point, that's not so bad. I kind of say...
It's topologically, it's equivalent, it's the exact same problem.
Well, yeah, that's right, but he says, there is that problem with the last point there, but he does indicate, but that's not consistent with that. That's not the Brentano picture. The Brentano picture is that when you cut it, you're actually taking these internal boundaries and splitting them.
Yeah. Okay.
Yeah. But it may be that in a later paper, or an earlier one, that this one supersedes.
I would like to ask you a question. So it's not clear to me how you understand the Aristotelian picture, and then how. In what sense is different, for instance, from Suarez? So, not that I know anything about it.
Well, I don't know much about either one of them.
So,
the blind leading the blind here.
If I have understood you properly, in the Aristotelian view, the points are defined in terms of segments, so limits.
In one dimensions, yeah.
And
in one dimension.
One dimension. So, in order to get a clear picture on the view, I would like to ask you, what happened when I just, what's the word, when I make 2-segment continuous into
one?
And then I split it again at exactly the same point.
So
what is the relation between those boundaries, and then how you create and destroy those entities seems pretty similar to Suarez. So,
all right, so what's happening? That's a good, all right, so this is what I think the line is. If there's any Aristotle people here, you can correct this. So we're starting off with our separates, say. Bring them together, then the 2 points that were at the endpoints of this one and this one, in effect, disappear. And what we have then is 1 point that's now exists potentially.
So only 1 point exists potentially?
Potentially.
Right.
And all that means is, I mean, it's not like it has any metaphysical status other than it's a place where the line could be divided. That's all that it means to say that the point exists potentially. It's a place where the line could be divided. He's not thinking of it as somehow separate. And then when, of course, you divide it again at the same point, then you're taking what used to be one potential point and you now get 2 actual points.
And what's the relation between those 2 points and the ones before the connection? None, or?
What was potential became actual.
No, that's very clear.
Yeah,
So we have 2 segments, A and B,
yeah,
and I would place it together into C, and then we split it into A prime and B prime.
yeah.
So what's the relation between the points of A prime and the point of A?
Okay, so A and A prime, one exists actually, one exists only potentially. There is that. Oh, no, you mean the...
No, both exist actually.
Oh, so
I split it again, so I put them together and
Put
then
them
I split
together, I see. So that's the A and A prime. So A and B, right, they're separate now. Put them together.
it.
All right, then split it again. Now, so take the left endpoint of A and the left, all right. Given that it's the same segment, A and A prime are the same segment, then it would seem to me that it'd have to be the same endpoint. Because the endpoints just are, they're metaphysically tied, they're dependent objects. It's just the point of the segment. So if it's the same segment, before and after, it's got to be the same endpoint. And you're sort of say a little bit sounding, it's starting to sound kind of Brentano-like, because there were one, but I think it's sort of, you're not thinking of the point as something that is independent of the segment. So you don't have to wonder about what happens to it. I mean, it sort of comes and goes with the segment. So A and A prime, in a sense, are only, so A and A prime are only when they're put together, A doesn't exist either anymore. It's just potential, and A prime as well. After the split, then intuitively it seems to me that A and A prime are the same. Now, if we're going to hold that, then presumably then their endpoints have to be the same. Does that help, or?
No, it helps, but then how is it different from, so could you maybe say something in relation to Schweiger, where things appear and disappear, because in this way, so segments appear and disappear.
Right. Well, because Suarez says, so maybe it's just, there might be a way to read Suarez as an Aristotelian. Right, maybe, right, maybe, right.
Maybe.
Yeah, but then the internal boundaries would only exist potentially. And the fact that there's only one, that would actually be rather telling. Right. But, of course, at one point Suarez actually says that when you divide it, the internal boundary is destroyed. And a new one is... We can translate that into Aristotle talk. That the potential is no longer potential, now actual. Yeah, so it's not too different from this little scenario we had in the first talk where you sort of reinterpret everything and it comes out as the same thing, so it's just a verbal dispute. Yeah, I can sort of see how that, how that might go. You'd have to sort of look at everything he has to say and see if we can get it all in there. Right, so if we interpret it to mean destroyed, meaning no longer potential, now actual, yeah, that might seem to fit. That would at least bring it closer.
Okay, any more questions?
Well, it's sort of related to this one. So I have to confess that I have no clear conception of what it would take to merge two segments or do such things with mathematical objects. But
no, that's an interesting problem.
So
yeah.
I don't know if maybe that's where my worry arises, but I find it puzzling to. So I see one picture in which the two endpoints become the merely possible one. But obviously it doesn't make any sense to say the two things become one.
No.
So we'd better say that the two things disappear and this other thing comes into existence.
Yeah, in the same place, something like that. Yeah.
But it's also, I also find it, I mean, if we think of the points just as endpoints, then it's not too worrying. But on the other hand,
that's the crucial move. Right.
Okay, so can you help me work through this, the relationship between the two things that go out of existence and this other thing that, the potential thing that starts to be there, and also in relation to the problem of what we are doing when we
Yes, so they're not really part, well, again, I don't know sort of how we're gonna handle the metaphysics, right? So the points are not really basic ontological items. They're metaphysically tied with the thing that it's an object of. And of course, and so if the thing doesn't exist, then neither does the endpoint. Right, so, again, so with the example we had here, so we had a segment that by itself, A, right? And we had another one, B, right? And they have their own endpoints. And then you bring them together, now A and B no longer exist, at least as actual things. So then neither do their endpoints. Right? Because the points are tied to the object. Now what's there instead is the place where the new thing could be cut. Does that help or not?
Yeah, and so we have to say also the segments that they don't no longer exist when we.
Not actually. Right? They only exist potentially.
So we cannot really say that they are potential parts of the thing, that they are.
Yeah, that's actually, I mean, I'm not quite sure that that's right, but that's the way it's been put to me by scholars, at least some of them, right? That continuous things only have their parts potentially. Right? So if you're thinking of mereology in a contemporary sense, as sort of Jeffrey and I do, where it's just, you know, there's nothing modal there, right? If you're thinking of the continuous thing as just having parts, right, then you're not going to get the right picture.
Yeah. I should also note like that this reminds me a lot of what Leibniz says about continuous, especially the last remark you made about the fact that it doesn't have actual parts but only potential parts.
Potential parts, right?
Yeah, it emphasizes this point a lot. Probably
Yeah.
also because.
Now, people have put this to me, they're not actually Aristotle scholars in the sense like Sarah Brody is, they're more like logicians who know more Aristotle than I do, like Marco Panza is one. And he actually made that line, he said that for Aristotle, continuous things only have their parts potentially. And he used the example of like a tree limb, right? So, and take like a part of the tree limb. It's only a place where you could cut the tree limb, but it's only there potentially. But the part is only there potentially. But that intuition is, I can sort of get my head around that. I can understand that for tree limbs and blocks of wood or things like that. But think of something else like water, like a body of water. I mean, that's intuitively continuous too. But that doesn't seem to have its part. That seems to be more where, you know, you want to see, no, there actually is a part there that's not just a potential part. But again, so I don't know what, Aristotle may not be that consistent throughout all this and what sorts of objects he has in mind. It is important that the continuous things, as we saw earlier, are unities. Now, what he means by that, right? But a continuous thing is a unity. And that also would fit in the idea it only has its parts potentially. Now, sometimes he talks about what the unity means is if you take part of it and move it, the whole thing goes with it. That would apply to the tree limbs, but not to the water or even like a wet enough dough or something like that. So I'm not quite sure what to make of these. And you are right that I'm sort of taking these distinctions and bringing them over to the mathematical realm of wondering what to make of them, and it's not quite clear how that's supposed to work either. It seems that according to that you're not going to get a distinction in the mathematical realm, in geometry, between things that are merely contiguous and things that are contiguous, the way you would in the, you're not going to get an analog of the books, right, the two books, right, the way you will. Right. So again, I'm not quite sure how to sort all that out.
Well, what are you thinking? What could the picture be like if you think about higher dimensional spaces? Because
Beyond 3?
yeah, well, beyond
Or
3,
beyond
4,
four.
whatever, yeah, because, I mean, that means that, for example, if we have a surface, and you cut the surface, you can cut it in different ways. You have a space of functions.
Yeah.
So that space of functions becomes something potential, not actual.
Yeah,
And
that's
that
right.
could happen with
Yeah,
any
5
dimension. So
Yeah.
what's the point of view that you have?
Yeah, well, again, that's, this is sort of well beyond anything Aristotle, whatever. I'm pretty sure that the account that Jeffrey and I gave him, it's not an Aristotelian fully, because we're making a lot of play with infinity. But that naturally extends to 2 dimensions, well, not so naturally, but with some work it extends to 2 dimensions, and from there on out, it doesn't matter from there. But you're not going to get this fully Aristotelian picture there about potential and actual. But the idea would still be that there's no points, right? Or they're not funny. You can always define points as limits, but you're not thinking of this manifold, whatever it is. It's not how many dimensions it has. It's just composed of points. One of the puzzles to me, that's going to be not irrelevant to what your question is. So one of the problems from that point of view is to try to make sense of continuous variation. That's in effect why functions were brought in historically, was to try to make sense of continuous variation. And there it is really natural to be dealing with points. And it's not obvious how to do it, right, on a more gunky framework. You know, I don't know if that helps, but.
Any more questions?
Yeah, so in some of the puzzles you explain presuppose that point-sized objects can have color. And you mentioned that in passing that it's not clear that
Yeah, it's
makes sense.
What the hell does that mean? Yeah.
Yeah, yeah. And
Light very well can't bounce off of it. Yeah,
That's
take a
okay.
wavelength or something, right? Yeah.
so I was wondering if points can have some properties that can be used to run that kind of puzzle, properties that are nothing like color.
Something else, I guess, right? You'd have to, and yeah, in terms of functions maybe, or something like that, or yeah, I'm not claiming that. We're not claiming that you know, the intellectual community made this colossal mistake by bringing points in. It's enormously productive, and in particular, you can handle things like continuous variation, you know, when you're dealing with points. Right? The question is sort of what, you know, how seriously to take this in the sense of metaphysics, because you can always bring points even into an Aristotelian picture as limits. Yeah, so then in effect you could talk about a point having a property like a color if it's, say, part of a region that has that color, something like that.
Like a relational property or something
Yeah,
like that?
something like that, yeah. If we're thinking of the points as somehow tied to the regions that they're parts of, you know, as Aristotle would, right, then in some sense it'll have the color because it'll have color because or properties like color because the region will. But the idea would be, well, what about the point itself, right? Right. And then it depends on what you want to make of it.
Anyone else? Sebas again?
So if we have the opportunity, the last of your slides started mentioning something that you comes to grounding and fundamentality, and then something came to my mind. I would like to ask you, I mean, just because you think it's interesting, what would be in this framework more fundamental? So the segments or those potential elements from which the line is made out. It seems
That's got to be
finding
yeah, that's
some
got to be
circularity.
That's got to be where, if there's going to be any metaphysical action here, it's got to be in that, as to which one's more fundamental. Because if you start out with a gunky space, at least if you have infinity in it, you can define points as limits, or as endpoints, you know, all Aristotle. If you start out with a pointy space like Dedekind-Cantor, right, then you can define regions, all kind of regions, as certain sets of points. So in particular, if you start with Dedekind-Cantor space, and you look at all of the regular open sets in it, right, you'll get a model of our theory. Right? I mean, not Aristotle's, but, you know, Jeffrey's. All right, so then part of me wants to say, this is the sort of thing I broached at the beginning and said we wouldn't have time for, that there's just no fact of the matter as to whether space, real space, right, is composed of points or not. Because you can do it either way, right, translate that and forth. If there is going to be an action there, it's probably going to be, or at least if metaphysicians are going to have have anything to say here, it's going to have to do with fundamentality. Because for the Dedekind-Cantor claim, what goes along with it is that points are the fundamental thing. And everything else is defined in terms of those. So points are fundamental, regions are derivative. Or, I don't know, what's the right word? Derivative, is that it? Or less fundamental. And for the gunky theorist, it would be regions that are fundamental, and points would be derivative or less fundamental. If that distinction makes sense, then of course you have a real debate. I mean, is that what you're asking?
Yeah, and also, just simply in your model, points are defined in terms of segments, so segments are more.
Or actually sets of segments, something like that. I mean, it's not unique to us. I mean, Whitehead has something.
But then segments are, I'm not sure whether this is correct, but segments are constituted in those potential points.
No.
Or
they're not.
potential
No, they're
points
not.
are also defined in terms
No.
of segments.
That's right.
So always segments are,
Yeah.
that's,
No, it's gunky.
yeah.
No, it isn't. We're not thinking
To
of.
get clear about this, thank you very much, that's
Right, so if you're thinking of fundamentality in terms of composition,
Yeah.
right, yeah, then you're just ruling gunky stuff out altogether. there isn't any bottom. But if you're taking fundamentality to be more in the sense of, how we're defining it, or if it's propositions that are more fundamental rather than stuff. Yeah, so if there is an issue there, it's gotta be that, right? I kind of think, although I don't have an argument for this yet, that the debate between an Aristotelian, or not an Aristotelian, but a gunky theorist and a pointy theorist one is merely verbal. Right? That's what I want to say, or that's what I think I want to say. It seems like a friendly crowd here to say this, and just take it back there. But then that would mean that, again, given the tests for merely verbal disputes, it means you could translate anything from one says to the other. Now, what about the fundamentality stuff? Because they're going to disagree about what's fundamental, right? So if I'm allowed to translate that from one to the other, then I can get the game going. But then, if you're kind of thinking, fundamental is this thing that's not up for grabs in these verbal disputes, then there is a real dispute there.
Anyone else wants to ask something?
You want to ask something unrelated to the talk?
How about the other pictures? Anyone, do you want to do this?
But you want to talk about anti-rent structuralism?
Yeah, give you like a relativism.
Oh, the new book. Oh, yeah, right. Yeah, at least that I can't claim that I just forgot. But probably should talk about that later. Yeah.
Okay, well, okay, one more question.
Don't worry about anything, because this just goes with my limited high school knowledge of numbers. But you mentioned Aristotle's thinking of numbers as discrete, right? Or is that
Yeah, real numbers are numbers.
Yeah. So how do you handle the real numbers if you're thinking of points as mere possible?
No, you don't. They didn't have a real. Real analysis is. That's like 16th, 17th century.
No, sorry. So not for Aristotle, but so if we think, does it mean that the space continuum is just going to be very different in structure than the reals?
Well, up to the idea that we can always translate back and forth. Yeah. So you normally want to think of a line as a right. We can actually embed this is something the Hellman and I do. You sort of take our gunky line. You can embed the real numbers in it.
Yeah. So I was wondering
As regions, not as points, right?
Oh, I see.
Right. So, so take like a number like pi.
Yeah.
All right. Well, obviously you need a unit. So pick an arbitrary unit, a region, an interval. Right. Intervals are intuitively Indian. Call that one. Then sort of take 3 copies of that.
Oh.
Right. That's 3. Right. To the right. You got to go. Well, sorry, you're pointing to the left. Right. And then take like 0.1 part of it, which again, and put that on, and then take the 0.04 part of that, of the original unit, put that on. Now here we're going well beyond Aristotelian resources, because now we're going to take the figure of all those, and that'll be, that'll correspond to pi.
Yeah, that's very helpful.
Right. So then we get in effect the positive numbers on the one side, and then the negative numbers that way. 0 is going to be the, going to be the kicker that you don't know what to do with that. But because we don't have any point-sized parts to But given that it's just 1, we just let that be anything other than, right? So that's part of my suggestion that you can really go back and forth between these. Once you put infinity on the table, in a very un-Aristotelian way, actual infinity. You take an actual infinity of regions and fuse them.
One more question.
Mhm.
Oh,
See?
you can ask any question.
Great. Now, I was thinking just a very quick comment on, again, the Brentanian solution. Earlier we were saying that, if I understood correctly, the Brentanian solution is that there is a multiplicity of points coinciding,
At
which...
each spatial point.
Yeah, exactly. And that sounds like a very profligate ontology.
Yeah, it sounds monstrous.
So one alternative would be to embrace contingent identity and think that actually there is one point which will become 2.
Which will become 2.
Yeah, I'm not a friend of contingent identity, but there is a whole legion of
Yeah,
people
no, but
who like that.
Yeah, no, I can sort of see that too. It'd be kind of like think of like an amoeba. It's
Yeah.
just an example, right? So it is 1, one amoeba, and then it splits into two. And you're not gonna wonder, well, which one after the split was, just became two. So you can look at it that way.
So I think there are at least two metaphysical packages that are actually consistent with the Brentanian solution.
Now, does thinking about amoebas involve contingent identity?
I don't know in the case of amoeba, but if we think of cases like the statue and the lump of clay.
Sure, yeah, then you get, or at least you kind of wonder, maybe it's identical for some purposes and different for others and things like that. But here it's something that's splitting. So the thought was actually my friend Graham Priest had suggested that when I gave a version of this, that you think of it as like the internal boundary point becomes two when it's split. Follow up
In
or
relation with that idea, what happens with the receptacles, with the status of those receptacles? I think
on the, what happens? Oh, you mean
when
so what is the receptacle? Is it the open thing or the closed thing? Yeah.
because we have points, and it happens that in some time, or I don't know if there were time here, because well, we have to talk about time and space.
Sure.
And sure,
Yeah.
it is time. But what happens in the with the status of receptacles? Because receptacles are chunks of the space that an object can exactly occupy.
That's right.
Okay,
That's
but
the official definition.
if the space well, we think the time and space as points,
That's composed of points.
and
Yes.
points have time as a dimension. Then what happens with that dimension in receptacles? I think I don't have any idea about
I
that.
see, yeah. So if you do it four-dimensionally or something like that, yeah, I don't know, I'm not a metaphysician, so, not to, how does it work really? Well,
No, my point after that,
yeah.
because I see some things similar to this opinion, that maybe I can send you by email.
Yeah, are you
Is
worried
that-
about like endurance and perturance and issues like that? Is that in the same area here? Are you worried about issues of endurance?
No, I would say that sometimes we put some physical things in our mathematical ideas,
Yeah.
and sometimes we don't.
Yeah.
And this creates a lot of problems, in my opinion. Here is one, another one is like, for example, with the idea of continuity, or the idea between relations with boundaries. When we broke something, for
Yeah.
example, obviously we think not only in two boundaries, but with three, because what happens with the broken thing, or something like that. Maybe
So
that's
you take like a vase and you hit it and break it up into all these pieces,
or it broken
Break it.
only like that.
or just say, just break it into two pieces. And
Okay,
then you say, what, there's a third thing?
yeah,
There's what, the original vase and then the two pieces afterwards?
before and after.
Yeah. So before you had the potential part, you had to put it in there into the terms.
Anyone else? Well then, in that case, thank you so much, Professor Shapiro.
Thank you.
Thank you very much for coming. I hope you are going to be able to come to our next talk. It's at 4 o'clock, and it's going to be Fernando Rubi talking about how to resolve Navi's paradox, about moral law and